So at the end of class yesterday, we were looking at this example of an angled projectile question. Okay? Worked just like the question with the general E that we had done before, but I think when I wrote the answers up, I may have accidentally had my calculator on my desk in radian mode, because when I did this with period 2, I noticed it was in radian mode. So I may have messed something up, so we'll just walk through the whole thing, because we didn't get to actually do the solution, okay, yesterday. So we've got this cannonball fired at a 40-degree angle at 140 meters per second. All right, so it's going to follow an arc that looks like that. Okay, its motion is going to have a horizontal component and a vertical component. So what we want to do is split up everything we know into the vertical and horizontal parts, okay, and get everything that we need. Right? So from a vertical perspective, okay, we know acceleration is negative 9.81 meters per second squared. And if we're talking about the whole flight, the displacement would be 0. Okay? But most importantly, we've got to calculate the initial vertical velocity from our projected velocity vector. Okay, that's the 140 at 40 degrees. Okay, so if I want to find VI, it's the opposite side. So I'll be using the sine of 40 times 140. So sine of 40 times 140, and it's going to give me 89.99 meters per second. And that will be up. Now, since it's launched and lands at the same height, what's VF? The same but opposite. Okay, so VF will be negative 89.99 meters per second. All right, everybody with me so far? Okay, we can also do this to find the horizontal component of that 140, that projected velocity, knowing that horizontally that velocity will remain constant. So that will be the cos of 40 times 140. Okay, so 107.25. Meters per second. All right, so to start off with, I'm trying to find the horizontal distance traveled. What do I not have that I need? Time. Seems like that's what we always need. Okay? So I'm going to go back to my vertical information, and I'm going to calculate it with that, because I've got VF, VI, and A, which means I can use this formula. Okay, I just have to manipulate it for T. So T will be 89.9 negative minus 89.99 positive, okay, divided by negative 9.81. All right, so when I take negative 89.99 and I subtract 89, I get like 2 times 89, right? Okay, so I'm just going to shortcut that and do this. Okay, oh, come on. Times 2, and then I'm going to divide that by 9.81. All right, so this thing is in the air for 18.35 seconds. Okay. That number can also be applied here. 35. Alright, so now I can do this. D equals V times T. Take my 107.25, multiply it by 18.35, and I will get the horizontal distance traveled by my projectile. I think that was the answer I wrote on the board. I wrote 2.0 times 10 to the 3 yesterday, didn't I? Okay, I guess I didn't screw it up. Okay, so we will round that up to 2.0 because we only have two significant digits. 2.0 times 10 to the 3 meters. Okay, that will be the horizontal distance traveled. So this cannon can shoot a cannonball 2 kilometers. Okay. Which, you know, for an old-fashioned cannon would be impressive, but by modern standards, modern artillery can fire things 20 or 30 kilometers with brutal accuracy. Okay. All right, the next thing we need to calculate is the maximum height the cannonball would reach. Okay, so to do that, we've got to go back to the diagram and recognize that our maximum height occurs, whoop, should have the right color here. Our maximum height occurs right here, okay, at the halfway point of the motion. Okay, so that'll be our vertical displacement. And what is VF at this point? 0. What's the time at this point? Half of the 18.35 seconds we calculated. Right? So one of two ways to calculate that displacement. Okay, use this formula and manipulate for d. So that'll be VF squared minus VI squared over 2a. Or use this formula. Remembering that the time needs to be half. Okay, either one of those will get us the right answer. Okay, so I'm going to take the 89.9 there, okay, and square it. That'll be the top, okay, divided by the bottom, which is 19.62. 2 times 9.81. All right, so it's going to reach a maximum height of 4.1 times 10 to the 2 meters. Okay, everybody with me there? Okay, and we will arrive at exactly the same number if we use this formula, okay, because we would take our 89.99 okay, and multiply it by, oh, I forgot to do this. Got to get that 18.35 in half. Okay, so there's VI times T plus 0.5 times negative 9.81 times that squared. Okay, we get exactly the same number doing it that way. So you totally have the choice. Either way will arrive at the right answer. Okay. All right, so now we've done a whole bunch that work exactly the same way. Okay. Now, here's one that's a little bit different. Now, you're looking for the angle that the ball is thrown at. Okay. You're still going to be doing a lot of the same steps, just in a different order. Give you a few minutes, see if you can figure that one out. All right, let's have a look at this one. So we know the object is thrown into the air at 35 meters per second at an unknown angle. So we don't know what theta is. Okay. From a vertical perspective, then, I know very little other than A. Okay. Other than that, I really don't know anything from a vertical standpoint. But horizontally, they tell me two things that can be very useful. They tell me the time, which is great, because now actually that goes over here in the vertical part as well. Not that I'm going to need it, but okay, it can go over there. And it can stay here. And that it travels 70 meters horizontally. So it does this, and that distance there is 70 meters. Okay, what can I calculate if I know the distance and the time?
Velocity.
Yeah, I can calculate the horizontal velocity, which is, in the end, this side of that triangle. Well, then I would have two sides. Can I get the angle from there? I don't even need anything from the vertical part of this. Okay, I just needed to get one other side of that triangle to get the angle it was thrown at. So I'm just going to go V equals 70 over 2.5. Okay, and now I've got that side being 28 meters per second, and now I can use the adjacent side and the hypotenuse to get the angle. So theta will be the inverse cos of the adjacent side, 28, divided by the hypotenuse, 35, okay, and that will give me my angle. All right, so we're looking at 37 degrees for the angle it was thrown at. Okay, but I still have to do pretty much the same things. Actually, this question was less work than the other ones that we've done because I didn't have to do anything with the vertical part. Okay. All right, questions on that one? Okay. This one's trickier. So you're looking for the velocity it was thrown at. So that's that one. And I will tell you that there is a bit of an algebra trick to this one. Okay, so we know that this object is going to go like this through the air. Okay, we don't know V, we don't know theta. Okay, from a vertical perspective, we don't know much. We know A equals negative 9.81 meters per second squared. And if we're talking about the entire trip, we could say that D equals 0 meters. Okay, but horizontally, they do give us a bit of information. They tell us that horizontally, the object travels 30 meters in 10 seconds. Now, that time can also go here. Everybody all right with that? Okay. So, if that's the case, and I want to get V, I need at least a side and the angle or two sides. Right? I need two other pieces of information about this triangle I know virtually nothing about. Right? So I'm going to calculate this one right now, okay? And I'm just going to go d over t, okay? 30 over 10, okay? It's telling me that this thing was moving horizontally at 3.0 meters per second. Right? Now, it's in the air for 10 seconds. That's a long time. And it's only moving horizontally at 3 meters per second. That tells me this thing was thrown at a pretty high angle. Because it isn't like at 3 meters per second, it wouldn't take long for something to reach the ground if it was thrown horizontally. So it's not moving very fast horizontally, but stayed in the air for 10 seconds. That means it went pretty high before it came back down. All right? That's just stuff I can kind of get from the context of the question. All right, so I know that this side here is 3.0 meters per second and that the triangle probably doesn't look like this. Okay? It probably looks more like this, like it's almost straight up. Now, here's the algebra trick. I don't know what VI is, but I need it because it's the other side of that triangle. But if we're talking about the launch point and the impact point being the same, what's the relationship between VI and VF? They're the same, but opposite. So here's the algebra trick. VF and VI have the same magnitude. That is, they're the same number. One is negative, one is positive. So could I do this instead? They are, after all, the same number. One's negative and one's positive. So I can just say negative v, because vf would be the negative one, minus v being vi, and it being positive. Did I just eliminate one unknown from my formula? Do I know the other two numbers? I know a and t. Okay, so this is kind of the algebra trick here. Okay, and that now negative v minus v is negative 2v over t. Now I can solve for v, which is the side of the triangle I'm missing. Okay, so I'm going to manipulate this for v, so I'm going to multiply both sides by t. Okay, that's going to equal negative 2v. I'll divide both sides by negative 2, and that'll leave me with v. So I'll have 10 seconds times negative 9.81 divided by negative 2. So negative 98.1 divided by negative 2. Okay, so VI is 49.05 meters per second up. Now that I've got the two sides of the triangle, and this triangle is obviously wrong, okay, or drawn not to scale, okay, I can now calculate both V and theta. All right, so I can do Pythagorean theorem to get V. So I take the square root of that number squared plus 3 squared. So I'm going to get 49.1 instead of 49.1, but slightly different 49.1. Okay, basically we're saying here that that horizontal part is so small that it makes virtually no difference. Okay. And then I can calculate the angle. So I'm going to use the opposite side and the adjacent side. So I'll go second tan of 49.05 divided by 3. Well, that seems to fit with what I thought. It's telling me that I threw this thing at an angle of 87 degrees above the horizontal. Almost straight up. Okay, and that seems to fit with the data I was given. So the speed it was thrown at is 49 meters per second at 87 degrees above the horizontal. Okay, it's a tricky question. Okay, I would say there might also be another way to get VI, and that would be using this formula. Whoop. Okay, we do know T, and we know A, and we know D is 0. Right, so we could solve for VI by going D minus 1/2 AT squared divided by T to get VI. That should also come out to a similar number, I think. Okay, so 0 minus 0.5 times negative 9.81 times 10 squared divided by 10 comes out the same number. Okay, could have done it that way too. Everybody all right with that? I wouldn't give you one like that on a test because it's kind of a math question as opposed to a physics question, and because of that algebra trick. But it makes you think outside the box a little bit. Okay. So on this one, we have this situation. The ramp is on top of an incline. Okay? So we're going to have this kind of happening. How high above the ground is the end of the incline? Okay, so the projectile or the ball is going to do this instead, and we know it's 30 degrees above the horizontal at 12 meters per second, and all we know is that it lands 1.4 meters from the base of the incline. All right, so this whole part here, nothing changes about this. That's the tip I'll give you. Okay? Nothing changes about that projected triangle. The sides still represent what they represented before. Right, so we want to do the same thing with this one as we've done with all of the others, okay? Including writing down important givens like acceleration being negative 9.81 meters per second squared, okay? But then also calculating the sides of our triangle. Okay, so for this one here, VI is the opposite side, it's a 30-degree angle, so the sine of 30 times 12 is going to be 6 meters per second, and that's up. Okay, we need our horizontal velocity as well. Okay, it'll be the cos of 30 times 12. Okay, so we're looking at 10.39 meters per second. Okay, and we also know that it travels horizontally 1.4 meters. Okay, what can I calculate with those two numbers? Time. Okay, and time is important because I can use it in the vertical part as well. All right, so we're going to have our 10.39 divided by 1.4. Whoops, sorry, other way around. 1.4 divided by 10.39. Okay. So it's only in the air for 0.135 seconds, okay, which is not very long. Right, so this diagram here is not right. It's definitely not this high off the ground, okay, but we don't know that when we start. Okay, so 0.135 seconds. Okay, that number can come over here to the vertical part, and I'm supposed to find out how high above the ground it is. Would that be the vertical displacement of the ball? It goes from the, right, the ball is going to travel from the top of the ramp down to the ground. That will be its vertical displacement. It's going to go higher than that because it's coming off at an angle, but in the end, its overall displacement is from the top of the ramp to the ground. Okay, so that's what I'm looking for. Well, D equals VI times T plus 1/2 AT squared, and I have all of that information. Okay, and this time I want to use the whole time when I use this formula. Okay, so I'm just going to plug in my numbers. 6 times 0.135 plus 1/2 times negative 9.81 times 0.135 squared. That number. Oh, let it leave in there. Okay, so it's saying that it's 0.72 meters tall. Okay, as our final answer. So not very tall, right? It certainly wouldn't take very long for something to fall that far. Okay, that's all we're looking at. Okay, that one making sense? I mean, in the end, is that really a whole lot more difficult than the other ones? Not really. Okay, we had to use a different acceleration formula, so okay, we've only used that one 1,000,000 times for the horizontal one. So there's lots of different ways I can ask these. Okay, tomorrow we'll spend some time looking at those, as well as a few more videos of good and bad projectile motion physics. Okay. Reminder, your vector assignments are due on Thursday. If you want to hand them in early, I'll take them.